Bismillahirrahmanirrahim. Assalamu alaikum. Let us see the definition of derivatives. A function f of x is said to be differentiable if the limits on the right hand side of this formula exist. Now note that if we are given any function and someone say to differentiate the following function by definition, or differentiate the following function by using the limit definition, or differentiate by using the first principle, or differentiate by ab initio method. In all these cases, we shall use this formula. So let us see the proof of this formula and solution of some examples. Let us differentiate this function f of x by using the method of first principle, which is also called the ab initio method. According to this method, we add delta y with delta x and delta x with x. In the next step, we transfer y to the right hand side. So we write f of x plus delta x minus y. And now let us substitute the value of y from 1. So we have minus f of x, which is the value of y. In the next step, we divide both sides by delta x. So we have f of x plus delta x minus f of x divided by delta x. And now we take limit delta x approaches to 0 on both sides. So we have that this is equal to limit delta x approaches to 0, f of x plus delta x minus f of x divided by delta x. Now the left hand side, this is denoted by dy by dx, which is equal to limit delta x approaches to 0, f of x plus delta x minus f of x divided by delta x. And this is called definition of derivatives by using the limits. So if the limits on the right hand side exist, we say that the given function is differentiable. And we can also write that dy by dx is equal to f dash of x, which is equal to limit delta x approaches to 0, f of x plus delta x minus f of x divided by delta x. Sometime we denote delta x by h. Delta x represents small changes in x. So if we represent it by h, we have f dash of x is equal to limit h approaches to 0, f of x plus h minus f of x divided by h. And this is called definition of the derivatives. In example number 1, we use the definition to differentiate the given function. So first of all, let us write the definition. F dash of x is equal to limit h approaches to 0, f of x plus h minus f of x divided by h. Let us say this is 1. Now here we are given that f of x is equal to under root x plus 1, and from this we can obtain the value of f of x plus h. Just replace x by x plus h in the given function. Now substitute these values in 1. We have f dash of x is equal to limit h approaches to 0, the value of f of x plus h, that is x plus h under the root plus 1 minus f of x, that is x under the root plus 1 and whole divided by h. Now let us simplify this. F dash of x is equal to limit h approaches to 0. Now if we multiply minus, we will have minus under root x minus 1. So plus 1 and minus 1 will cancel, and we get x plus h under the root minus x under the root divided by h. In the next step, we have to rationalize this. So just multiply and divide by x plus h under the root plus x under the root divided by x plus h under the root plus x under the root. And from here we can get that f dash of x is equal to limit h approaches to 0, and in the numerator we use formula a minus b into a plus b. So this is equal to a square minus b square. So x plus h under the root whole square minus x under the root square and divided by h into under the root x plus h plus under the root x. And let us simplify this. So we have limit h approaches to 0, x plus h minus x, and whole divided by h into x plus h under the root plus x under the root. Now minus x and plus x will cancel. So we have limit h approaches to 0, h divided by h into x plus h under the root plus x under the root. Now this h will cancel with this one. So we have limit h approaches to 0, 1 over x plus h under the root plus x under the root. And now let us apply the limits. So if we substitute h is equal to 0, we have f dash of x is equal to 1 over x under the root plus x under the root. So from this we get 2 under the root x, and that is the required solution. To solve example number 2, we use the same procedure. Let us write formula of f dash of x, which is equal to limit h approaches to 0, f of x plus h minus f of x divided by h. Let us say this is 1. Now in this question we are given that f of x is 1 over under the root x, and from this we can get the value of f of x plus h, which is equal to 1 over x plus h under the root. Substituting these values in 1, we have f dash of x is equal to limit h approaches to 0, 1 over x plus h under the root minus 1 over under the root x divided by h. Let us take the LCM. So we have limit h approaches to 0. And from this, the LCM is under the root x into x plus h under the root. And we have under the root x minus x plus h under the root, and this h which is in the denominator will come here. In the next step we have to rationalize this. So we write f dash of x is equal to limit h approaches to 0 under the root x minus under the root x plus h divided by h under the root x under the root x plus h. We will multiply and divide with under the root x minus, sorry, this is plus x plus h under the root, and we will also write x under the root x plus h under the root. In the numerator, again we use the formula a minus b into a plus b, which is equal to a square minus b square. So according to that formula, we write limit h approaches to 0 under the root x square. So we get x minus under the root x plus h whole square. So from this we get x plus h if we multiply minus inside here. So we get this thing divided by h under the root x under the root x plus h into under the root x plus h under the root. Now here minus x will cancel with x. Similarly, h will cancel with the h which is in the denominator. So we have limit h approaches to 0 minus 1 over x under the root x plus h under the root into under the root x plus h under the root. Now applying the limits, we have just put h is equal to 0. So we have under the root x into under the root x, and then we have under the root x plus under the root x. Now from this we can get 1 over under the root x under the root x. From this we get x, and from that one we have 2 under the root x. So if we further simplify, we get f dash of x is equal to 1 over 2 x under the root x, and that is the required solution. Let us use the same procedure to solve example number 3. So formula for f dash of x is equal to limit h approaches to 0 f of x plus h minus f of x divided by h. Let us say this is 1. Now in this question we are given that f of x is equal to x square plus 2x plus 1. From this we can get the value of f of x plus h, which is equal to x plus h whole square plus 2 into x plus h plus 1. Let us substitute these values in 1. So 1 becomes f dash of x is equal to limit h approaches to 0. And now here we shall write x plus h whole square plus 2 into x plus h plus 1 minus the value of f of x, which is x square plus 2x plus 1 whole divided by h. Let us simplify this. So if we simplify, we have limit h approaches to 0. From this we have x square plus h square plus 2hx. From the next term we have 2x plus 2h plus 1. If we multiply minus, we have minus x square minus 2x minus 1 and whole divided by h. Now x square will cancel with minus x square and plus 1 will cancel with minus 1. Now plus 2x will cancel with minus 2x. So we have limit h approaches to 0, h square plus 2hx plus 2h divided by h. And from here we get that f dash of x, this is equal to limit h approaches to 0. Taking h as common, we have h plus 2x plus 2 and whole divided by h. Now h will cancel with h and we have limit h approaches to 0, h plus 2x plus 2. Now let us apply the limits. So we have f dash of x is equal to h is 0. So we have 2x plus 2 and that is the required solution. To calculate the derivatives of a function f of x at a given point x is equal to a, we shall use this definition of the derivatives. We shall find the left hand derivatives by using this formula, which is just the left hand limit, and the right hand derivatives by using this formula, which is just the right hand limits. Now the left hand derivative and the right hand derivative, if they are equal, we will say that the function is differentiable at a point x is equal to a. Otherwise, we will say that the function is not differentiable. Its proof is very simple. We just plug in x plus h is equal to a in the first formula. And from this we can get the value of h, which is a minus x. And we can see that as h approaches to 0, the value of x approaches to a. So just using these substitution in the first formula, we get the required result. To solve this example, let us write the definition of left hand derivative. L f dash of a is equal to limit x approaches to a negative f of x minus f of a divided by x minus a. As these are left hand derivative, so we shall put the value of f of x for which x is less than a. But a is 2 here. So let us substitute a is equal to 2. And from this we get L f dash of 2 is equal to limit x approaches to 2 minus f of x minus f of 2 divided by x minus 2. Now at x is equal to 2, the value of f of 2, the value of f of x at x is equal to 2 is given by 2 minus 2, which is equal to 0. And for left hand derivative, f of x is minus x minus 2 when x is less than 2. We are taking left hand derivatives. So using these values, in one we obtain L f dash of 2 is equal to limit x approaches to 2 minus. Now the value of f of x is minus x minus 2, and the value of f of 2, that is 0. And this is divided by x minus 2. From this we get minus, okay, let us write the limits. Limits x approaches to 2 minus, and here we have to write x minus 2, there is minus divided by x minus 2. They will cancel with each other. So we can get that L f dash of 2, that is equal to limit x approaches to 2 minus 1. And when we apply the limits, we can get that the answer is minus 1. Let us say this is equation number A. So LF dash of 2 is equal to minus 1. And now let us write the definition of right hand limits for derivatives. So we write RF dash of A is equal to limit x approaches to a plus f of x minus f of a divided by x minus a. But as these are right hand derivatives, so we shall take limits for which x is greater than a. Let us substitute the values. But here a is 2, so we shall write r f dash of 2 is equal to limit x approaches to 2 plus f of x minus f of 2 divided by x minus 2. Here now we can write that at x is equal to 2, the value of f of 2 is 2 minus 2, and this is 0. But when x is greater than 2, in that case, the value of f of x is given as plus x minus 2. So let us substitute these values into, and we have r f dash of 2 is equal to limit x approaches to 2 plus the value of f of x is x minus 2 minus the value of f of 2 is 0 divided by x minus 2. And from this we get that limit x approaches to 2 plus x minus 2 will cancel with x minus 2. So we get 1 here. So we can see that r f dash of 2, that is equal to 1. Let us say this is B. Now look at from A and B. Left hand derivative of the given function a2 is not equal to right hand derivative of the function a2, and this implies that limit does not exist. So as limit does not exist, so we can say that f of x is not differentiable at x is equal to 2. Using the same procedure, we can prove that these functions are not differentiable at the given points. That's all.